Okay, you guys, we are doing 11.3 volume of pyramids and cones today. Again, the formula is going to go, the two problems or the two solids I'm doing together because you'll see the formula how similar they are. Okay, so we have volume of a pyramid. So when we learned yesterday or last week the volume of a prism, so if you can, here's a good way to remember it. The prism and the cylinder have two bases. And when it's two bases, it's base times height. Whatever the area of the base is times the height of the actual prism. When you're doing a pyramid, if you think about it, this almost looks like a prism with a base. And the way we can do it is if we have one prism here, one pyramid here, if I put another pyramid here and another pyramid here, you can kind of visualize that, you'll have three pyramids into one prism. So the way you think about that is if this is my prism formula and three of these fit into there, here is the volume of a pyramid. 1/3, because this is 1/3 of a prism. So it's 1/3 base times height. So try to remember one base, it's 1/3 of the prism in a way. And we all remember B is the area of whatever the shape of the base is, the area of the actual base. So you'll have to calculate that. And that's all you have to do for pyramids. So as I told you, volume is so much easier than surface area. It's not as complicated. And yes, today's lesson is going to be slightly longer because I'm going to do two of them, but I'll try the best I can to make it go quick. Okay, so the first example is pretty straightforward. You have a regular pyramid with a square base, and it's shown in the diagram. Side S of the base is 12, so this is 12, and the height is 42. So this is a very basic just example just to get you guys going with your formula. So I like you guys writing your formula, 1/3 base times height. Sometimes I like you guys I would recommend replacing the base with whatever your shape is. So you're thinking, and now your thinking's out of the way, and now you're just inputting the numbers. So we have 1/3. The area is a square, or the base is a square, so the area is 144, and your height is 42. Put that all in the calculator, and you get your volume to be 2016 meters cubed. Remember, volume's always cubed, while surface area is squared. Done. Very basic example. Okay, let's take a look at the next one. So we have the base of a pyramid is a rectangle, width of 6, length of 8. So, if you want a picture, we can do that. Find in centimeters the height. So now I'm looking for the height of the pyramid if the volume is that. So here we go again. You guys know I like writing this. Let's replace that B with the area of the base, which is length times width. That's the area of it times the height. And then you're just putting your numbers in. So you have volume is 288 equals 1/3. Length times width is 6 times 8. So 48 times my unknown height. Put it all in the calculator. Divide 1/3 of 48, divide, and we should get X, which is my height, to equal 18. We could say centimeters. Great. That's simple. Okay, number 3. Find the volume, okay, so now it wants the volume of a regular square pyramid. So let's do this again. Volume pyramid, you see it's 1/3, it's a square, so let's do side square times your height. So it wants us to find the volume if each base edge, I didn't mean that, if each edge of the base, so that's how you know. Let's draw a picture for us. So each edge of the base is 10, and if it's a square, let's already put some numbers in here. So 10 squared, we have 100. Slant height. So this is the height of the pyramid, and they gave me slant height. So what we have here is they're telling me the slant height is 13. So again, if you remember, I told you the years past when people took the exams, the hardest thing is understanding the different language. So that is not the height of the pyramid. So we have to find the height. This is our height. Well, we know how to do that. Let's form your triangle. So this is your apothem, and you know that in a square, this apothem is 1/2 that. It's just the way it works. You can prove it if you wanted to. So that means this is 5. Do Pythagorean theorem so you guys can find it, or you should know your triple. And you guys get your h to be 12. So we put the 12 in here. We calculate it. And you guys get your volume to equal 400, and it's in inches cubed. Done. Hopefully you guys are thinking, wow, this is so much easier than surface area, as I told you. I don't lie. All right, find the volume of a hexagonal pyramid. All right, so I'm gonna write the formula right away. We have 1/3 hexagon, the area of a hexagon. We got 1/2 apothem perimeter times the height. Always write your formula in, and then you're just using it as a guide. All right, so we all know you always have to do stuff for your hexagon. So let's draw the hexagon. Okay, and it says the base edge is 4, so we know that's 4. We have the slant height again. So we're gonna have to do some work here. Probably should have given myself more room. Slant height is 6. So again, get the right information down. It's not the lateral edge. It's not the altitude of the pyramid. It's your slant height. Okay, so let's see what we have here. We have 1/3, we have 1/2. Can you fill in any of your numbers? I can fill in my perimeter. You guys know I like to fill stuff in to get things out of the way. So if one of your base is 4, 4 times 6, 24. All right, let's go ahead and find my apothem. All right, so we know we have this here. We have this here. We know that this guy is 2. We know that this little one is 2. You know, doing your 360 divided by 6 divided by 2, that gives us 30 up here, and your 60. Hopefully you guys can know this by now. So 2 is across from the 30, so apothem 2 rad 3. So 2 rad 3 is my apothem. Now the question remains is what is the height? So here we go. We have the height of the pyramid is what we're looking for. Now recall I told you the different triangles that we create. If you're given their slant height and you want the altitude or you have an altitude, you are always using what's the third side? This side, and this side is your apothem. So that's how you guys do it. I'm gonna take that out. So here's your 6. We don't know our height. This is your apothem. And we already found our apothem. Our apothem was 2 rad 3. So again, you have to make sure you're using the correct pieces. One more time, we'll do Pythagorean theorem. So you have your x squared plus your 2 rad 3 squared equals 6 squared. You guys should put it in the calculator or actually you should be able to do it in your head. You should get x squared equals the square root of 24. I thought I changed this. I want this as exact. If you guys can give me exact, and on the homework I want you doing the same, give me exact, otherwise you can round to the nearest 10th or 100th. So we know the square root, hopefully you know the square root of 24 is 2 rad 6. Done, you found my height. Here you go. Put it all in the calculator, or put 1/3, 1/2, 24, and 2 in the calculator. Okay, so this becomes 16. Now, since you have 2 radicals, you can always multiply your radicals. So 6 times 3 is 18. But we have to simplify that. What perfect square goes into 18? 9. So 18 simplifies to 3 rad 2, and then we multiply those numbers, and we get 48 rad 2, we'll say units cubed because it's volume. So stare at that for 1 second, make sure you're okay with that. Again, apothem here, that should be easy by now. And then what we did was, remembering the slant height, the height uses your apothem. We did Pythagorean theorem. I simplified, subbed it in, multiplied all of the quote-unquote outside numbers, got 16, inside 18, and we simplified that from there. Okay, 2 more problems for pyramid, and then we're going to talk about cone, which was only a few problems for because it's the same kind of formula. Okay, here we go. We got the volume of a pentagon. Pentagon. That means you should hopefully recall you're going to be doing trig to find the area. Okay, so let's draw it. The best you can. Okay, now you have to, again, told you, read carefully. Lateral edge. This is your lateral edge. It's the edge of one of the lateral faces. It's not your slant height and it's not the height. And the base edge, so down here again, is 12. All right, let's put our formula in as always. We have volume equals 1/3. Let's replace the base. We have 1/2 apothem perimeter times the height of the pyramid. Let's see what numbers we can put in. 1/3, 1/2. I don't know my apothem. I do know the perimeter. 12. 12 times 5 is 60. And I do not know the height of my pyramid. Okay, so here we go. So obviously for this one, it can't be exact. So we're going to find this one to the nearest 10th. Okay, let's find our apothem. Alrighty, so we know we have this. We know we have this. We know we have this. I'm just going to take that triangle out. It's a little harder. So since this is 12, half of it is 6. We all know 360 divided by 5 divided by 2. We got our 36. Okay, let's go find our apothem. Okay, so we'll put X there for our apothem. So now it's opposite, adjacent. So you should know it's tan. So tan 36 equals opposite over adjacent. Cross multiply, and then you gotta divide. You should get X equals about 8.25829. Remember, don't round, ... This value is my apothem. Oh, kind of right. Yeah, I left myself enough room finally. 82582, some numbers. Check, got my apothem. Okay, and you can always kind of, multiply it at the end, put all the numbers down. Now here's the problem. We need our height. So let's put our height in our picture. So in this case, since you have a slant height, there are a couple of things you can do, but to make your life easier, not having to calculate another number by calculating, let's say, this is the lateral edge. So not having to calculate, a slant height or anything like that. When you're given the lateral edge and we're working with our height, what connects it? This. The line that connects it is our radius of the polygon. So this one is definitely a lot more complicated. I should have left myself more room. The question is what is the radius? Well, the radius is this. So I'm going to put a Y here, and I'm going to come back to this picture. Wow. And I'm going to put a Y there. Okay. So if I'm going to use that, I'm going to do opposite over hypotenuse. So I'm going to do sine 36 equals opposite over hypotenuse. Cross multiply, and you are going to get the value to be about 10 points. So again, hopefully you're watching this is complicated one. This again is our radius. So now I found this. Now I finally want, I'm just going to put an H there, the height. So I want the height. All right, well, let's figure out. You have this, which is the radius right here, check. And you have your lateral edge, so you will do Pythagorean theorem. Again, I know this one is a lot. So we're going to do H squared. Let's do a different color so you guys hopefully can follow. Plus the radius squared is this, so I'm just going to put 10.2078. Hopefully your calculator, you still have it squared, equals 15 squared. Do the math for it, put it all in your calculator, and you should get the height, square root and all that stuff, to be about 10.99. Again, just check that you guys get these numbers. Don't round. 3, ... And that is your height. and we put that height right there. So this is, you should get when you're doing this, make sure you get these numbers, something like that. I know it's kind of crappy. Maybe I'd write all the numbers down and then put it in the calculator. Your final answer with 1/3 of 1/2 of your apothem, which is 8.2 something something, times the perimeter of 10 times the height of the pyramid at 10.9, you guys get 907.7 feet cubed. So yes, that is a lot. So here we go again. This one was for your apothem if you guys are doing it with me, so you have your numbers. This was for the radius, and this was for the height. And there's your final answer. All right, now we're gonna go on to doing the frustum problem. Again, I apologize, today's lesson, yes, it is long. You all know some lessons are longer than others, and some of them you don't even have a lesson because it's a worksheet. So today is definitely gonna be a little bit longer. All right, so let's do our frustum problem. Finding the volume, we have a square base. Your concept is the same. So let's draw this so we have our visual. This is their last problem for pyramids. Yikes, that was pretty bad. Anyway, so there's your frustum, the best we can draw, or the best, I should say, I can draw. So how do we do this? Oh, it looks kind of weird. That made it worse, but we're continuing. So if you think about this again, like we were doing for all of our frustums, you know, you want to think that this is continuing pyramid, and I'm cutting it off. So recall what we did last time to find the surface area of a frustum. We're going to find, in this case, the volume of the big or the whole pyramid. All right, and I still recommend you guys writing this. Great, so finding the volume of the whole thing. Then we're gonna minus, again, it's not surface area, so that's why this is so much easier. Then we're just gonna get rid of the top pyramid. Minus the volume of the top. And that is it. You're not doing anything else. I told you it's so much easier than surface area because you're not covering anything. You're just you're subtracting, like you're filling this whole pyramid up. And then I wanna get rid of that top part, which again, you're filling it up. So it's so easy. So let's write our formula. We have 1/3 base, so side squared times the big height, minus 1/3 side square of the top one, minus the height of the top. That's it. Hopefully you believe me. So the square base is 4 on the bottom, 2, and the height is this height. You have to be aware if I'm talking about the height of the pyramid or if I'm talking about the slant height. All right, let's try to figure out some of our numbers. Well, let's see what we have here. 1/3 side of this is 4 squared, so 16. Do we know the height of the whole pyramid? No, I'm gonna come back to it. 1/3 side squared, 2 squared is 4. And do you know the height of the top? All right, so we have to find it. Remember, this is how you guys are finding it. In this case, you're not working with the slant height. Surface area, we did work with the slant height. You're not doing it in this picture. So you don't care for it. You're gonna set up the same proportion. I'm gonna put an X here. If you wanna use your apothems, you guys can, obviously half of the numbers, but as long as you guys are staying with the same comparison or the same numbers, in this case, you can use the sides. So again, X, you can use your apothems or you can use the side. So I'm gonna do X over, I'm gonna use my side, make my life easier, 2 equals X plus 3 over 4. Cross multiply, 2X plus 6 equals 4X, I'll write it out. And then you guys subtract and do the work, and we get X equals 3. So this guy's height is 3. So much easier. So the whole height is 3 and 3, so the whole height is 6. The height of the top is 3. Put it in the calculator. The volume of this frustum is 28 inches cubed. Done. It's that simple, you guys. Promise. Surface area was your heart. I'm done repeating that. All right, let's talk about cone. Again, if you want to stop your video now and do your pyramid questions and then come back for cone, you can. I apologize, it's long, but because it's the same kind of concept. Your cone. So here we go again for cone. Tell me, how many bases do you guys have? You have one base. So we just talked about this. If you think as comparison to a cylinder, if I put a cylinder here, you have 1, 2, 3 cones. So the volume formula for a cone, one more time, is 1/3 base times your height. Just like your pyramid. So think when you have one base, it's 1/3. Now, the base does not change for a cone. Well, what's the area of the base? This is always a circle for a cone. So we have pi r squared times your height, which is similar to your cylinder, except 1/3. Radius, height, again, slant height in case where you talked about it. All right, let's go ahead and do our problems. We only have 5 problems. We'll try to go quickly to make your video go faster. All right, so we have a cone. It has a height of 9, really easy one, and the circumference is 12 pi. What is the volume? So let's write our formula. Again, I would just right ahead go and put the volume of this area of the base. So it wants to know my volume. I got 1/3. I got pi. What is my radius? So that's what you're looking for. Well, if this is your circumference, we all know circumference formula is pi d. So 12 is the diameter. So radius is 6. Perfect. 6 squared, height 9. Let's find our, can we find our exact, I think I did, this was a multiple choice question, I changed it. 1 second. So we have 1/3 times 37. Yes, let's change this to doing exact. So exact means put 1/3, 6 squared times 9, and we get, oh my God, 108 pi centimeters cubed. Done. That's how easy the cone formula is. The first problem I wanted to make, just always really basic and pretty easy. Okay, we're almost done, you guys. Number 2, find your exact volume. Remember when I say the right, it just means it's standing upright. Circular cone, the radius is 6 and your slant height is 10. All right, so I'm gonna draw the picture first, and then I'm gonna write my formula. Okay, so we know radius, 6, slant height is 10, not the height. I've seen you guys get confused between the difference of the slant height and the regular height. Easy, radius 6 squared. The actual height is this. And we all know we can do Pythagorean theorem, and we know our triple is 8, so put the 8. Put that in your calculator. Let's do we said exact. So you get 96 pi inches cubed. Done. That's simple. I would say just be careful because volume deals with the height, while surface area deals with the slant height, and you're going to be seeing it more. So make sure you write all your formulas down. Okay, number 3. What is the diameter? All right, so I want the diameter, so you're working backwards. Height 6, volume 314. All right, so let's put our formula in here. We have 1/3 pi r squared, height, volume 314 equals, where's my problem? 1/3 pi, don't know the radius, so I'm gonna put this times my height, which is 6. All right, so in the calculator, we can do like 1/3 of 6, which we all should know is 2, so this becomes 2 pi r squared. I'll do the math out with you. Then you're gonna divide by 2 pi, but please, please, you need parentheses. So put it in parentheses, you're gonna get r squared. Whatever you get here, you need to square root. So I'll do it with y'all. So we have 314 divided by parentheses, 2 pi, close it, enter. Y'all should get about 49.97 something. Square root that answer. You should get your radius to be about 7.06 ... Times this by 2 because I want the diameter to the nearest foot is a whole number. Done. All right, 2 more problems and you're done. So your favorites, the frustums. Again, it should not be that hard. It's just like your pyramid. Well, how did we do the pyramid? Remember, I told you it was really easy. It's not like surface area. You just take the volume of the big and you minus the volume of the top. The same thing is happening here. So let's write that out. Let's guide ourselves. We got the volume of the big cone. Think about that. And then you want to get rid of the top cone, so you want to minus the volume of your top. Let's put our formulas. Okay, so let's put our numbers in. We have 1/3, we got pi. The radius of the big, well, this is the whole thing, so you know your radius is 6. Do I know my height of the big? No, because obviously, you're going to have to find that. Minus, all right, we got 1/3 pi. The whole diameter up here is 5, so you know your radius is 2.5. Oh, pen kind of went away. And we don't know the height of the top. All right, I'm just gonna cover that one up for one moment. So I should have wrote smaller, and oh, that's why I put them separate. I was supposed to write here. Well then. Okay, so this is the height. It is not the slant height. The slant height, they would put it on an angle. So we have the height. We don't need to work with the slant height because, again, we want height. So I'm going to put this here because it's easier for me to see. And then we're going to go up, and I have that. Okay, again, I don't need to split the diameters to the radius. As long as you're in the same comparison, you're fine. So x is the height of the top over the diameter of the top equals x plus 11, the height of the whole cone, over the whole diameter of 12. If you want to put the radius, you guys can cross multiply, and you end up getting about 55 over 7, or you guys can say 7.857. I don't care what you guys do. It's just easier for me to write that. All right, that is the top. So we have our top number. Let's put it in our top spot. Okay, and then for me to find that, I'm just going to take this and we're going to add 11 to it because you want the whole thing, and 11 is here. If you add 11 again, or you can add 11 to this, it doesn't matter to me, but I'm just going to keep it because it's easier as my fraction. Put it all in the calculator, and you should get, we're going to round to the nearest hundredth. 659.47 meters cubed. Done. Okay? Hopefully not that hard. Now let's take a look at this one. Can't really cover that up, so we're just going to go here. All right. Kind of sloppy, sorry. Let's do the same thing. You know you're doing volume. You have the frustum. So we got the volume of your big cone minus the volume of the top. We have 1/3 pi r squared h. I forget something, no. Minus 1/3 pi r squared h. Okay, let's put in the numbers that we know. We know we got 1/3. We know we have a pi. The radius, oh, they gave us, is 15 squared. Do you have the height? No, you're always going to have to find that. Minus 1/3 pi, radius 12 squared, height. Okay, now the thing that's different with this one is the 5 is our slant height. Hopefully you see the difference between this one and the last one. They went like that to show you the height. This is 5. Now, in surface area, we want the slant height. We do not want the slant height here. We want the height. So let's work our way backwards, which we did plenty of times. We want this. 12 left over is 3. Life is pretty simple when I give you guys easy numbers, right, with Pythagorean theorem. 3, 4, 5, it's one of your triples. So you know your height of that is 4, but we're not looking for that. We're looking for the height of the whole thing. But yes, I would work with that. Always kind of go with what you want. So there you go. Now we can do the x up there. All right, so let's set that one up for ourselves. So we know we have the top, which is x. over, we'll just use the 12 again, whatever they give me, equals x plus 4 over the whole bottom, which is 15. Crap, I didn't do this one out, so now I gotta cross multiply. So 15x equals 12x plus 48. Okay, minus, you get 3x equals 48. Right now, I'm second guessing myself. Okay, so x is 16. Yay! Which means the full is 16 and 4, so the full height is 20. And, oh, I mean to do that. Your top height is 16. Put it all in the calculator, and let's round to the nearest hundredth. Now I second guess. Let me just put this in the calculator. 1/3 pi. Let's do 25, but let's do 15 squared times 20 minus 1/3 pi 144 times 16. And you should get grand finale 2,299.65 inches cubed. Done. Surface area, volume, that's simple. Hopefully you guys found it pretty easy. We went through the pyramid and the cone. Again, same formula, 1/3 base times height, and the base is whatever the shape of the base is. All right, you guys.